We're going to be using grid parameters and other options to fine-tune contour maps. We'll be using existing hand-drawn contour layers to add data points to a map. We'll be using Zone Manager to import isomap values and then build other attributes to be used as isomap sources. We'll be creating bubble symbols based on well-based data and how this data is read, and we'll be creating thematics to highlight areas of interest and altering the data attributes to see how that data is read as well. So without further ado, we'll go ahead and jump on over into the demonstration. So what I got here, I've got some pre-built layers. These are going to be isopack layers that I've created here, and what we're first going to do is create a sum isopack layer based on these three. So right now you can see we have these three layers overlaying on top of each other. A bit of a mess, but we're going to clean those up and combine them together using the isomap grid operations. And what these are, they're simple equations to combine data. You can do either like an A minus B, A plus B, any type of equation you can put in there. What we're going to do is a simple A plus B plus C, and update our grid variables and assign isopack grids here to these variables. And last one, and we're going to set this third one as our key grid. You will have to have a key grid selected to build this layer when we're doing this. So we're going to build that, and right now we're going to keep everything default. We'll come back and look at these here in a bit. Essentially, these are going to be our grid settings and our data value options. So we'll be looking at those in a bit here. So I'm just going to name this layer sum isopack. Next, let that layer get built here. And we're going to keep these options default as well, and go ahead and build our layer. So now we're going to turn off these other layers. And so we've got a nice summed isopack map here based on the three source grids combined together. Now what we're going to do is we're going to turn on the grid for this this layer here, and we're going to read some of our values, and we're going to jump this up to about 250 to improve the look of the intervals here. So you can see in some of the areas we had bullseyes. We've kind of smoothed those out a little bit to make them easier to read. So if we zoom in here, we can look at the grid values. So this is going to be your grid mesh. The grid mesh is going to be used to build the contour layers based on wherever a contour line crosses a grid, it draws a node. So we can view those nodes if we click on turn on our nodes over here and click on a contour line. You can see everywhere that the contour crosses, it draws a node. And to fine-tune some of these areas, you can see it's a little messy over here. We can decrease the size of our grids here to have more columns and rows so that there's more points for the contour to draw on. So to do that in a grid operations layer is a little bit different than a build surface layer. We're going to change the number of columns and rows. As you'll see later during a build surface layer, we use the smallest feature radius and radius of influence to control these values. In this case, we're just going to change them here manually. So we're going to do about 200 and about 175. We'll click OK. And again, when we start messing with the values here, the more grids that you throw in here, the longer it takes to build the layer, and that's because it's taking a longer time to decrease the size of the grid and then thread the contours through those grids. So the smaller it goes, the longer it takes to draw. So click Finish here. Let that build. You can see the grids are a lot smaller, and we have a lot more nodes to play with now around some of these contours. So we zoom out. You can see we can start fine-tuning in some of these areas. And what we can also do is in some areas where we have grid values that maybe we don't want to use, like say we're building a isopack map based on porosity values, where we start getting negative values in our grid, and we don't want negative values to show up, we can null those out or create a minimum and maximum grid value to remove those values. So we can come over here into our build parameters and our data values tab, and we can set minimum and maximum values in here. We're going to set our maximum value to about 6400 and say that any grid value that is larger than 6400 will be set to 6400. And you'll see it'll start removing some contours in some areas and smoothing out those contours. So click OK to build that. Again, taking a little bit of time here because we've decreased the size of our grids. And click Finish. And go back to full extents. You'll notice in areas down here where before we had some contour values and other grid values there, no longer there. Every grid value over here is now about 6400, and we can kind of smooth those out and set the value to whatever we choose in that area. So now we'll look at the color fill options here and how that will be affected. So we're going to do color fill. We're going to keep it at color fill density, and in our spectrum we're going to change our value here to white because we're going to exclude these areas. And you can see the using the color fill option that we used here, it's coloring in the grid values in these areas. And we do have a few areas out here that might have grid values less than 6400, so they're not being nulled out. And then this is just sort of a preference on your part. You can set that lower or higher based on the data that you're working in. Like I said, in cases where you might have negative grid values and you want to zero them out, you can set a minimum value of 0, and anything less than the minimum will be set to the minimum. In this case, we're going to just leave the 6400 there. And again, the color fill gradient that we're using here is filling in the grid values here, so it'll fill in every single grid over here. So you can see as it's coming out, the gradient reaches 6400 and starts going to white. So again, this is all dependent on your data set. So the values we're using here for the either the data values here or the columns and rows values here are going to be project and map specific. In areas where there's a lot more data or you got a bigger map to cover, maybe values like this won't be a very good fit because of the amount of time it takes to grid the map, or just based on the type of data that you're using. And we'll look at that also with the smallest feature radius. Again, the value is very dependent on the type of data that you have. So we'll click OK, and we got our map there. So again, this is a summing and isopack based on the grids that we've created here from the map. What we can also do is import these isomap values into Zone Manager and build a map a similar way. So we got over to here to Zone Manager, and I have my well zone open here right now, where I have these 3 attributes that are just based on the 3 isopacks that I had created. And all I did to get these is an import of my isomap values. So you can come over here and do a File, Import, Isomap Import. And we'll choose the layers we want to import, the zone we want to import into our well zone, and then the attribute that we want to import into. For a first-time import, you'll probably want to create a new attribute, giving it a name, units, and data type. Are not necessarily dependent or anything like that. And you can set the number of decimal places you want to have show up on your attribute there. Oh, do I already have these? Since I already have these created here, we're just going to use these. And you can use the attribute calculator to create a similar attribute what we did before, a simple A plus B plus C, this time choosing to sum up our attributes instead of grids. but it'll produce a similar result. We have a sum isopac value here that we can now use to create a isomap in GeoAtlas using the isomap build surface with the zone manager source based on the attribute that we've created. So we get our well zone and our attribute and click OK. Then you can see there's our values ranging. We got 698 points to create that map. And when we create it, it will look similar to the map that we saw before. And, after some tampering, you get back to a similar location, but that will be using the build surface options, which we'll be covering here in the next section, with some contour grids, hand-drawn contours. So I think this will be a good place to stop and ask questions about grid operations and zone manager transfers.
Hello, everybody. Andrew, okay, we have one question. Let me read it. Under grid operations, Andrew said key grid. How do I decide which of my grids in the operation is the key grid?
The key grid is going to come down to, I guess, user preference. Let me just get this back up here again. When we use the options in the build surface or the build, the grid operations options, there's the options to choose the output grid values based on which one you set as your key grid. Again, this is what we're doing here is we're just summing the values together. So when we look at our grid values, we'll have values around 6,000 and 7,000 based on the summation here. The key grid is just going to be based on which grid is being used to draw these on. Which grid, because we use either the grid from this layer here, the grid from this layer here, or the grid from this layer here. The options are going to be similar in the end, because it's just summing the values together. So again, it just kind of comes down to preference there. I'll look at that real quick. Yeah. The grid extents are going to be based on the key grid, and since these layers are all sort of at the same extents, then the key grid's very similar in this case.
So they say that basically you're using the parameters from that key grid.
Yeah,
that is correct.
Set the extents there, right?
Mm-hmm.
And since these are all again in the same area, the extents are all similar. So in this case, it's just user preference.
Yeah, that is why always a user have to be very careful with the extents, because you can use whatever layer they have a below extent, and when you use it as a key, you're going to destroy the entire map. And all the calculation, everything is going to be pretty bad. So be careful with the extents of the project.
Right, right. So in maps with fixed extents and good extents, then the key grid will be fine there.
Okay, so no more questions for now, Andrew. So you're good to go, man.
Okay. So like I said, we're going to move on into contour to gridding and the build surface options. So I'm going to take one of my hand-drawn contour layers here. That I've created, and these values are ranging from about, if I can hover over it, from a z-value of 0 to a z-value of 100 over here. And in some places we have values jumping from 40 to 100, 50, up to 90. So in some of these places when we do the contour to grid, you're going to see some contours being drawn in between these values, because we're going to be doing an interval of 10, so every 10 feet is going to be drawing another contour in that area. So we can, contour to gridding, we can kind of fine-tune our contours by choosing to by messing with the smallest feature radius, the radius of influence, and a z-value substitution. So the first thing to do is to do a contour to grid. You go to contour, contour to grid, and you select the layer that you want to contour based on. Again, we're going to be using our hand-drawn contour layer here, and we're going to name this CTG for contour to grid. And we're going to be using adaptive sampling and have it about 400 meters or so. And then what this is going to do, and we'll turn on the data points to look at in the map when we get there. This is creating a sample data point from our hand-drawn contours every 400 meters on that contour line. So the coarser you go, the fewer data points are going to be used to create that contour. The finer you go, the more control you'll be getting, and the closer you'll get to your hand-drawn contours. Contour to gridding is it can be kind of finicky, and again, it comes down to the user options in the smallest feature radius to get it as close as you can to your hand-drawn contours. You know, it's very difficult to get it 100% correct, but with these options, we can get very, very close. And we're going to save our contour nodes as display points here. And we're going to make these 0 to 100 based on their hand-drawn contour values with an interval of 10. And let's do that. Go ahead and finish and build that there. So you can see our hand-drawn, our contour to grid layer is fairly close. In this case, we do have a few bulges out here, a little over here, one over here, and some contours outside of our area that we didn't draw on. So what we can do is, using a boundary polygon, we can exclude these contours that we didn't, aren't part of our data set, and then we'll use the smallest feature radius to kind of get these fit a little bit closer. So we can go to update the layer. We'll create a new boundary polygon. The boundary polygon is essentially going to draw around our data points to the extent of that. And once we've drawn that on there, we can take the data nodes of the boundary polygon and shift those anywhere around we want to exclude areas or include others, and kind of set it up like that. And then once we update, we'll just choose to use the existing boundary polygon instead of creating a new one each time. So for right now, we'll do create a new one. We'll come over here and look at our grid spacing. So different from the grid operations options we saw before, where we just had to change our columns and row values here. Here we can alter the smallest feature radius. This is kind of the same kind of effect. The smaller the value, the smaller the grids themselves. The greater the value, the larger the grids. You'll see once we change the smallest feature radius to something like about 400, we'll notice that our columns and rows have increased in number based on what we have here. The radius of influence is going to be used based on data points from your map. So in areas where we have sparse well control or sparse data control, we can set a radius of influence around those data points. So we can say at a certain, say we have a z-value of 500 in one area, and then the grids are extending out into an area where there's not a lot of well control. We can increase that radius of influence to go further out, and say, the further out we go, the more control that data point has on the grids going out. We'll be looking at that a bit here, a bit more in a bit. The radius of influence always has to be at, greater than your smallest feature radius. So when we have a smallest feature radius set at 400, the smallest radius of influence we can have is 401. So again, we'll be looking at that here in a bit, and we're going to lock these grid parameters so that anytime we update the layer or refresh data sources, it's going to keep these or create new boundary polygons. It's going to keep these values and not change them at all. So I'll come over here and click OK. And regrid. Again, remembering every time you change either the contour interval or your grid parameters, you'll need to regrid, which will also recontour for you. So you can see now we have the contours that are outside are no longer there. In some areas, our contours are being, our hand-drawn contours are being a little bit more follow it a bit better in some of these areas. Again, the bulges out here are still there. The one we had over here is gone. Still have this one in here. But we can either use the snipping tool and join the endpoints to snip this area out and combine and then just join these two endpoints together to create this continuous contour. Remembering once we do that, we'll have to do another contour to grid. Anytime you either hand draw contours or hand edit contours on a map, the next time you regrid and recontour, it's going to go back to looking the way it does in this case, where it's got the bulge here. And this is because the data points are still pulling from this layer and not the ones that we've hand edited. When we can add those hand edits as data source either with a contour to grid, or we'll be going over adding hand-drawn contours as a data source in the next section here. So again, we can keep dropping down our smallest feature radius here to give some more control. Oops, on the hand-drawn contour. Let's go back to this one. Go to our build parameters here. We're going to drop this down to a much smaller value. When once we click out of there, we'll see now we have 1,000 columns and rows. Again, remembering this, the smaller we go, the longer it'll take to draw our layer. So again, the everywhere that a contour crosses a grid it's going to draw a node. So in the smaller your grids get, the better the control you have on those contour lines. So you can see it's getting a little bit smoother in some of these areas, especially around our zero contour on the outside. And so we can keep dropping that down to a value that we deem fit. So like I was saying before, when these values are not going to be consistent across all maps and all layers and all projects. These are going to be very specific to the data you're using and the size of the map you're working in. So a value of 50 on a map that's much larger will maybe start to cause issues when gridding that map because it's taking so long, or in areas where the contour interval is too small that you get some splining errors and stuff like that. So you have to increase the contour interval and increase the smallest feature radius just a little bit until you find that sweet spot that works just for you. So what we're going to do this time though is we're going to take our radius of influence and we're going to drop it very small to just 51. Remember, it has to be at least one larger than our smallest feature radius. And what this is going to do is going to say every time we have a contour data point, we saw those earlier, those are the red cross signs on our contours. This is going to say every 51, I believe, feet in this case, it's going to be where that how much that affects the grids around it. So we'll see here in a minute that we're going to get some very interesting looking contours and a lot of blank areas around it. It's going to take just a little bit to write the grid here. Let me turn off this. So you can see around some of these data points, we get very small radius of influences. We only get a little bit of contour control around here, and we get a lot of blank space out in here. And we can use z-data filtering and z-data substitution to control some of this blank space. So what we're going to do is we're going to look at our geologic tab in our options here. And we're going to set our z-value to 0 in this case. So what this is going to look in some of these areas where we don't have a lot of well control, and it's going to apply a 0 z-value interpretation in these areas. So again, this is going to produce some interesting contours around this area due to our very small radius of influence. So if we zoom in here, we'll notice previously we had a lot of blank space. We now have a lot of 0 contours, and there's a 10, 20, and so on based on the contour interval that we have set up. And this is all due to the very small radius of influence value that we have set for our data points. So if you're looking to work in maybe some discontinuous isopac values or sand bodies, you can alter that by creating a small grid spacings with some small radius of influences, and then throw in a geologic z-value interpretation to substitute in some of those areas. We're going to bump this back up to its default here, and bump this back up as well. And go back to our default our map we were looking at before. And kind of like I was saying before, with hand-drawn contours and the contour to grid, it's really difficult to get it 100% perfect to what your hand-drawn contour is looking at previously. But using these smallest feature radiuses in the radius of influence or in the z-value substitution, we can get very, very, very close. Like I said, and also with the snipping tool and join to endpoints of some of these contours, you're going to remove this bulge and connect these contours, and then remembering to contour to grid afterwards to honor that new grid. Again, anytime you update the layer and regrid or recontour, it's going to go back to its previous state based on the data points that we have selected here. Okay, so we'll move on to the next section here. We're going to be adding hand-drawn contours as a data source to an existing map to control areas where we don't have a lot of data control. So we're going to come over here to our layers. And we're going to add this layer here. And this is a subsea map based on some subsea pics for the Red River Formation. You can see everywhere is a red dot. These are our areas where we have data. So we got a lot of data control up in here, around in here, around in here. Then we're going to get up in this corner, and we don't have a whole lot of data control. And we want to kind of influence the contours in this area. So what we can do is we can add hand-drawn contours and add that as a data source to our existing map. Previous to what I was saying before, adding hand-drawn contours on an existing map and then regrading and recontouring will remove that those contours because they are not part of our data sources. So what we'll have to do is we'll create a blank layer and use this sort of as tracing paper, and then add that existing layer as a data source. So to do that, we'll come up here and go to Layers, Create Blank Layer, and we're going to create an isomap, and we're going to call this a contour layer. And so now we have just sort of a blank layer here. We'll use that as tracing paper, and then we're going to contour on this active layer. And we're going to set this this one here to negative 10,000 to match the contour that is this one right here as our negative 10,000 contour. We're going to use that to influence some points down to about getting in here to the orange zone. So we'll take this and draw down to about here. And so now we have just a single contour line with the value of negative 10,000 that we can add as a data source to our map here. Oops, gotta switch to the other one. So we'll come over here, update our layer, and we're going to look at our data sources. And we're going to add our contour map here. And we can add various sources here, either from well-based data, information, subsea values, MD values, any kind of pick data there. You can choose zone manager sources like we saw before. You can import any type of data into Zone Manager through an ASCII import, create an attribute for it, and then use that as a data source. Or we can choose to use an existing layer, which we're going to do in this case, which is our layer we just created here, our blank layer with the hand-drawn contour. Oops. And we're just going to take the z-value field is going to be our converted XYZ data. And so now we have another data source at negative 10,000. The data sources you see listed here do not have any specific hierarchy, meaning that if you have our first source being the top subsea values, and then a second source having another set of subsea values from a different formation, it's not going to say, okay, I'm going to use this first, and then the areas where I don't have a lot of well control, I'm going to read the next source, and then if there's no data points in this area, I'm going to use the next source, and so on. That's an enhancement request that we've been working on with development currently to set this up as a hierarchy list. As it is right now, it just reads all the data sources that you've entered and determines a best fit that the program and the grading algorithm thinks will be best used for your map, which isn't always the best, which is why we'd like to set up the hierarchy so that users can determine what they think is going to be the best fits in certain areas. We'll see here, we get some altered contours, and click Finish to regrid. And I'll turn this layer off. Now you can see we have some data points added up in here along the contour that we've added, and we can continue to add contours to that layer, and in other areas. Again, the same way, draw a contour, and we'll set this to -10,500, and we'll draw it over here. Here's our -10,500 contour, and we'll add some more data points on this side. So now we have two hand-drawn contour lines, and did it again. We're gonna update this layer, and we're just going to refresh our data sources. Since we already have that hand-drawn contour layer as a source, this will refresh it, and it's going to read the new contour line that we've added. That's okay. We'll look over here, and now we have the -10,500 and -10,000. So we'll finish. Now you can see we have a few edited contour values here. You're having some more data points added along that contour to edit that area. So you can add these hand-drawn contours to create data points in certain areas where you previously didn't have any data points to control. And this is pretty good for previously what we were doing before, using a z-value substitution in some areas. This is another way to alter that in a few areas, just by choosing where we put these new data points with the hand-drawn contours. Okay, we're going to move on to the last section here, where we're going to cover the bubble symbols and thematic mapping to highlight some areas that we want to pay attention to. So we're going to switch over to our well-based layer here. And these are just going to be some well locations. Now, the only type of data we have on here right now are well IDs. And you can see some production symbols that are left on there from the previous session. Essentially what we can do here now is we can look at the data attributes that we have available for our well spots. And these are going to be the attributes that we're going to use to create production bubble maps, or bubble maps with any other type of data. And it's going to be pulled from these data attributes. So you can see right now we've got well ID, well status, some cum oil and gas volumes, and the depths associated with them, and an oil rate based on IP values, and some other information based on the IP table. This well currently doesn't have any values. That's okay, we'll look at some of the other ones in a minute. And oil volume based on IP, and then a value brought over from Zone Manager called ROC, which is a rate of change equation that I did, and an MD value associated with that, and then some subsea values. So these are the data attributes that we have currently on our well spot layer, and we can add or remove data attributes here dependent on what we have in our map tip bin. So when you update your well-based well spot layer here, anything that you have in your map tip bin is going to be what's posted on your well attributes. So right now, again, we have the based on our an attribute from Zone Manager, the ROC. We have IP oil volume and oil rate values, allocated cum values for oil and gas based on, I think it's a summation of all producing formations, and well status and well ID. And we can add other values up here, any kind of core data, DST data, some other formation data, base MDs, top MDs, any type of data we want to from up here, and zone attributes, depending, again, any type of data we have in Zone Manager we can post in here, either through on the map or through bubble symbols. You can just select the attribute that you want to add in there. So we'll leave this as it is right now. And we're going to look at the bubble symbol options. So again, based on what I have in my map tip bin, you can post various values, either cum oil and cum gas, volume based on production, top depth associated with that, oil volume based on IP and the top depth associated with that, ROC values pulled over from my attributes in Zone Manager, the measured depth associated with that from Zone Manager, and then my datum elevation and top subsea values. You'll notice these are only the numeric values that I have selected in my map tip bin. Any attributes that I put in my map tip bin that are not numeric values or are numeric values entered into a non-numeric table in Wellbase will not be displayed by my bubble symbols. So if we can go over here and look at Wellbase, if you look in the IP tab, oil rate was one of those values, and if I right-click on it and look at the unit of measure, you can see it's not a numeric field. So even if I had imported some numeric values, say from a spreadsheet or something like that, or entered them in by hand, even though it's a numeric value, it's not a numeric field, so it won't show up in bubble symbols. They will show up as thematics, however. So again, you can kind of just look in here and click onto these tables and view the unit of measure, and if it says not a numeric field, then it won't post numeric values. If it gives you a unit of measurement, in this case barrels, then we can post it as a bubble symbol. So we can change our values in here just by clicking in here and entering values that we want to, say 0 to 1. This one's not a very good one because these are all decimals. We'll do 0 to 0.1 or something like that, 0 to 0.2. And you can change the intervals put in here. Anytime you put in, say, we'll do 0 and 1 down here, and we ramp our values, it's going to determine some values that it thinks are going to be the best fit. And you can change these by increasing or decreasing the number of intervals put in there. And we can change the attributes of our what we're doing here, either circles, squares, triangles, any type of data we want here, and increase the size and of our bubble symbols, meaning smaller values will have a smaller bubble, larger values will have a larger one, and they can map on top of each other. Stack them this way, drawing smaller bubbles on top. And just based on any type of value that you want, you can change colors as well, similar to before, ramping colors. And we can choose to post these in the surface location, bottom hole location, or any formation intercepts based on this data. In this case, the ROC values shouldn't have any formation intercepts, so we'll just post on surface hole locations. And check it on, click OK. Now you can see we have some areas where we have our rate of change. We've got a lot of rate of change over in these areas. And then very little kind of out here in the middle. And we can choose to look at some oil production values as well. Oops. Based on any type of data we can choose here in the field. Thematics work a little bit differently than the bubble symbols. Thematics are tied to a specific entity type. So right now we're looking at a straight hole well. The only thematics we can view are going to be the data attributes that we put in our map tip bin for those values. So in this case we have well ID, well status, oil rate, which we saw before was a non-numeric value, it can show up in the thematic field here, and you'll see each well will have a certain count to it. So we have 283 wells with a BPD. We have 95 with BBL, 12 with BPH, and so on. And we can set these up with varying colors and varying sizes. Unlike before with the production symbols, we can't put ranges in here. We can only put individual values. So if you wanted to map, a certain range of values across, so based on some data from Wellbase, you can only do that through bubble symbols and only with values that are numeric. We can also create our own entity types to highlight certain areas that we want to focus on. In this case, through, as similar to before, you can apply either to the bottom hole or surface hole or formation intercepts. Yeah, we can also apply these to our own entities. You can create your own entities by coming to the Entity Definition Manager and adding a new type, adding some subtypes to it. In this case, we're going to be looking at the Polygon draw entity here with some zone subtypes that I have in here with some attributes called A, B, and C. And then when we create these and add values to them, we can map thematically based on them. The ones that are created by the system are not editable. So in the case of a boundary polygon or something like that, there's data tied to it, but you cannot insert or remove that type of data. Entities are also map layer specific. So if you try to draw a boundary polygon on a well spot layer, you're out of luck. Boundary polygons are specific to certain types of layers, and you can check that here by looking at the usage. So you can only draw these on Esri shapefile layers, GeoAtlas layers, ISOMAP layers, and SDE layers. So when you're creating an entity file on a layer, you want to create a landnet layer. Landnet layers are, all entities are usable in a landnet layer. And what we can do is you can create a blank layer again, choosing landnet as the type, and you'll be able to draw whatever type of entity you want on there. So we're going to switch over to our entity layer here. We're going to choose the polygons that we had created previously, polygon draw, and we're going to draw some of our zones. Since we have that selected, we can go to our pencil tool, and yes, gotcha. We can draw around some areas that we want to focus on here. Again, I'm not very used to laptop mouses, so this is not going to look very pretty. We'll just map a few out here, choosing some areas that we're interested in. Geez, really bad. So once we've created some entities here, we can assign values to them in the data attributes. Again, data attributes are very key in this case. You saw before I have an A, B, and C data type for these zones. So I can put in values here. And once I assign some values, we can start mapping thematically based on those values. So we'll go over here to our define thematic symbols. And you'll see in this case we only have one entity type drawn on this map, so we only have a few choices limited to us, being the three attributes that we have selected, A, B, and C. And once you click on it, you'll see we have our values that we've entered and the number of them that we have. So we have 1 with a value of 1, 2 with a value of 3, and 1 with the value of 2. And if I check it on, we can map these out and highlight various areas based on any type of values that we input into our entities. And you can choose, in some cases you can choose entities that you don't want to draw. Say we don't want to look at our pink zone here, and set these to transparent. And we'll set our entity line to no line as well. So now you can see we only have a few selected ones here. And we can change the style on any of these anytime if we just want to look at a few of them at a time instead of all of them. So I think that's a good place there to stop if we have some questions on bubble symbols and thematics.
Thank you, Andrew, for the explanation. And so far, I don't see any question. Just give it a few seconds.
Give it a minute here.
Please.
I think we'll be wrapping up after this session here. And so any questions you have going forward from this, we will be posting this webinar, like you said, next week. So if you watch it and you a second time, like, oh, I wish I asked this at this point, feel free to always email us, and we'll be able to take a look at some of these questions and answer them for you.
Nope, no questions.
No questions? All right, so we'll move on to the conclusions here. So when you're working in a map with isomap layers, manipulation of your data is going to be very key to improving the quality and look of your map. And to achieve this, we can add contours to our map, we can add boundary polygons, we can alter our build parameters to the smallest feature radiuses, z-value substitutions, radius of influences, and these will get the best solutions for us that way. Zone manager data can be used to create isomaps from imported values from various modules, either the query builder or spreadsheets, and we can put in the zone manager and create an isomap either from that as a zone manager source. Bubble symbols and thematics can be used to highlight specific data or areas of interest, and data attribute manipulation is key to this. So remember, only numeric values can be posted on a bubble symbol, and they can only be posted within numeric tables within Wellbase. I think that's